Guys, and welcome back to a new video. Room is finally available for Kotlin Multiplatform. And in this video, I will give you a quick introductory guide on how you can set that up for your Kotlin Multiplatform project and have a shared database that works exactly like Room with annotations, with a DAO. So in case you already have a native Android project that uses Room and you want to migrate that to Kotlin Multiplatform, you are now one step closer to that. And in fact, the demo project I will create here is a Compose multi-platform project, so also one that shares the UI between iOS and Android. And in order to create such a Compose multi-platform project, you need to go to kmp.jetbrains.com because there is no inbuilt wizard yet in Android Studio that allows us to create a Compose multi-platform project, but JetBrains offers this wizard where we can enter a project name, a package name, tick the platforms that we want to work on. So in this case, Android and iOS. You could also add desktop, web, and server, but we will be fine with Android and iOS. You can download this. That will be a zip file you need to extract, and the folder that you extracted is the empty blank project. You can then paste in your Android Studio project folder and then open that in Android Studio. And this is how it will look like. So we will have one Compose app application module. We will have some Gradle scripts by default. And the first thing we want to do is we want to add the necessary dependencies to Gradle. We already have a version catalog. So let's open libs.versions. And here we now need to add Room. And I will just paste these versions, so you can just write these off or also copy paste them from my GitHub repository down below. On the one hand, we have a Room version, which needs to be exactly that one. So starting from alpha 01, 2.7.0, alpha 01. Starting from that version, it supports Kotlin Multiplatform. We then want to use KSP, so the code generation that Room relies on, for Kotlin version 1.9.23. And we will use an SQLite version, which is the database framework that Room is built on top of. We also want to make sure that we are using the Kotlin version 1.9.23, which seems to be the case. So that is the default version that the wizard creates when we download the project at this point. So we can go ahead and add our Room library, so the actual dependency reference down here. Those are 4 dependencies. On the one hand, the normal Room runtime, which now works for Kotlin Multiplatform. We have the Room runtime for Android, so the Android implementation specifically, since it differs a little bit how we need to create such a database reference on each platform. We have the Room compiler, so what we need to implement with KSP. We have SQLite bundles, so the database driver that this Room database runs on. And lastly, we can paste our Gradle plugins. On the one hand, as I said, KSP for code generation, and the Room plugin, which creates some schemas, generates helper code for our database, deals with auto migrations and all that stuff. One more thing we need to do in order to make this run is we need to go to Gradle properties, and we need to add this line here. So Kotlin native disable compiler daemon. This is just something that currently needs to be set to true because of a bug, or otherwise there could be a crash issue. That's something they communicate that way in their docs. I don't know the exact reason why this needs to be enabled, but it's something we need to do. And then we can hit sync now that we have these dependency references at least in our version catalog. The next step is to also add them to our project. So here we have our Gradle file for the Compose app module, which includes all of our dependencies. And here we can now apply all that. On the one hand, for our Gradle plugins, so we can say alias, we want to include the libs plugins.ksp on the one hand, and our Room compiler plugin, Gradle plugin. Then we can scroll down to our common main dependencies. So those dependencies that we want to include in our shared code section. Here we want to have an implementation libs Room runtime on the one hand, runtime. And we want to have a libs SQLite bundled. Then we also need to add the KSP Room compiler, which doesn't work here inside of this dependencies block, because here we have a little bit of a different dependency handler. So here you will notice if we have KSP and we say libs Room compiler, that won't work. Also not after syncing. Let's do that. You will notice, okay, we actually get an error because we can't apply KSP here, but we can very well apply this by having a dedicated dependencies block down here. Let's open this. Here we have KSP libs Room compiler. We also need to define a schema directory. So just a directory where Room will put our database schemas when we have migrations, where it will save the information for that. We can do this with a room block. Don't worry that it will mark this as an error right now because we haven't synced this successfully yet. But in here we can set a schema directory, which should be our project directory, and a new schemas directory inside that. We can then try again. Hopefully this sync should now be successful. That is looking so. All right, you can see the errors are going away. KSP is recognized and our dependencies also seem to be available. So the next step is to define our database schema. So I want to just have a little people table here where we save some people. Let's do that in Compose app common main. So our shared code section, that is now the magic part that Room works inside that shared code section. Let's actually also switch to the project view. That's a little bit better here. Open Compose app source, common main, open the Kotlin source set. And in here, let's create a new directory called database. And inside that, I will first of all create our person entity. So in the end, our table. Make that a data class. And this now works really just the same as for Android. We need to annotate this with entity. And in here, we need to give this maybe a name. So every single person has a name and has an ID. So let's keep this database table really simple, just for the demo that you know how to implement this in a KMP project. We have an ID, so primary key, which is 0 by default. So we want Room to actually auto-generate these. And we can do this by annotating this with primary key and setting auto-generate to true, importing, primary key. And that is already our database table. Next step is to create our DAO, our data access object, in which we define those functions we actually want to have in order to interact with our database. So to insert something, to delete something, to query data. Let's also do that here. So we have a people DAO, make that an interface, which we annotate with DAO. Then here, let's first of all, let's start with the get all function, tap to complete, import query. We actually don't have a people class, but just a singular person. Let's also call this get all people. We then want to have an upsert function. So to either insert or upsert something, function upsert with a person. I like this auto completion. And we would like to have not get person by ID, but rather a delete function. Delete, and there we go. Delete person. And we need to make sure that these are actually suspend functions, by the way. So we want to use coroutines. And here for getting all people, I also want to get that as a flow. So let's wrap this result inside of a flow. But then we already have our DAO. So here with this flow, we're notified about new emissions whenever our database changes. So when we delete a person, then this function will emit the new list of people. And lastly, what we need for a Room database to make it work is a database class. We can do this here in our package again, call this people database, make that a class. It needs to be an abstract class, which needs to inherit from Room database. Needs to be annotated with @database to let Room know that we're dealing with a database here. And then we need to specify our entities as a list. And here we have, not people class, but person, class. And we need to specify a version, which is 1. If we have some kind of migrations later on, we would need to increase that version so that Room knows, okay, there's actually a new version. I need to run some migrations and so on. And lastly, in here, we need a people DAO, which works really well with this auto completion. All right. Now that we have the very basic setup for our database, we also need to find out how we can now create an instance of this people database so we can in the end use it in our code and show a list of people. Creating this instance is a bit different on iOS compared to Android. So on Android, we need to use a context reference in order to create a database instance, while on iOS, there is no such concept of a context. So it works a little bit differently there. In order to create this instance exclusively for Android, we need to jump into our Android main source set, which is our Android safe area where we have access to all Android specific dependencies and therefore also to the context. We can open this here, and in here, let's also have a database package inside that Room KMP package, and then we have a get people database function. So that'll just be a plain Kotlin file with a get people database high-level function. We make that return a people database, and it needs a context reference, which we very well have here inside of our Android main module. All right, in here, we first of all need to specify a DB file. so the file where our database gets saved to. And you can see the AI already suggests exactly what I want. So we use context get database path and call the people DB. And then, no, we don't want to return people database, but rather return our room.database builder, pass in our context.application context, and the name of our database should be our DB file, and we take the absolute path of that. Then we can configure this a little bit more. Oh, we also need to specify the type of DB we have here. So people database. And then we set the driver to our bundled SQLite driver, which we've included with a dependency. And then we can call .build. And that's how we create a database reference now on KMP for the Android side. Let's now also find out how we can do this for iOS. Let's not copy this. Let's go to iOS main, so our iOS save area. And in here, we also create a database directory. And inside this database directory, we have a get people database function. Function get people database. This does not take any arguments. On iOS, that's a bit simpler. In here, we also need to specify a DB file, which can be NS home directory. So the iOS equivalent to the home directory of the app to the internal storage. And then we say, okay, we actually add our people DB to the end of that path. And then we can say return room database builder again, make that a people database, give this a name of our DB file, which is already a string. And we need to specify a factory. So that is a bit different compared to Android. And this DB factory needs to be created quite weird. So here we need to say people database class that instantiate implementation. This function will be generated after rebuilding. It also happened to me that this stood in red even after rebuilding, but you will notice that when we launch our app, it will actually run without any issues. So don't be confused that this is marked as an error. Let's also just set the driver here to a bundled SQLite driver, build this, and then we are ready to go. So now that we are able to create a database, we need to also make use of that and display it in our UI. Our UI in a Compose multi-platform project is located in this app.kt file here in our common source set. Let's open that. There is some default code. Let's actually get rid of all of that and define our UI here. First of all, we want to pass our people DAO here, so we can make use of that here in our code. We can observe all people, by people DAO, get all, collect as state. That is almost correct. We just called it get all people, and we can work with that. Then let's also get a reference to a coroutine scope that is aware of the current composition, since we will need this to execute functions of this DAO. And as a first step, we open a launch effect true block here, just to have something really simple where we can insert some entries into our database so we actually see if that works. So let's have a people list in here. So just a list of people we want to insert. We have a person. Give this a name of, I don't know, John. Then we have Alice and Philip, something like this. And then we can loop over this list. So we say people list for each, and we just take our people DAO, upsert, and we insert this person. And if that already exists with the specific ID, this function would just update the existing entry. All right, now we have some entries in our database. The next step is that we actually show this in a little lazy column. So we have a lazy column, add a modifier, fill max size, give this maybe some content padding of padding values, 16dp, there we go, import both that. And then in here we have an items block where we loop over our people, get a reference to every single person inside that list, and then we have a text that displays its name. So the text is person.name, and we can say, okay, we have a modifier of fill max width, and we give it some padding of 16dp. In between, let's just make this a clickable modifier so we can also delete a person, just to have a very simplified way. Here we need to launch a coroutine in our scope, and then call our people DAO, delete, and we want to delete this current person we clicked on. And that's already our very simple UI. We now, of course, need to pass this people DAO to this application composable, let's take a look at where we call this by holding Command and clicking on that. On the one hand, in our main activity and in our main view controller. So in here, we have our iOS Compose UI view controller wrapper, which translates our composable into the iOS world kind of. And here we can create our DAO by saying is equal to remember, and we create our database reference with get people database and refer to the people DAO. I have to say, this is of course a very simplified example of how we get reference to a DAO. Of course, in a real project, I would use some sort of dependency injection setup that we really make sure that we have a singleton here for this database instance and then inject this from a safe place, from a safe module. But just for a quick demo, I wanted to create this here directly inside the composable so we can pass it to our application composable. Then we can jump into main activity. So that is the Android side of things. Here we also need to pass this DAO, and I want to get rid of the preview here. And let's just create the DAO here. Again, doing this in the onCreate function of main activity would be terrible in a real app, since it would be recreated after configuration changes. But we want to see how this works on KMP. So we can say get people database, need to pass in the context, and we can just say, okay, application context. We then pass it down here, and we need to refer to the people DAO like this. And I think that should be everything we need. So I've connected my device and we try this out. First of all, Android, and then we of course also want to see if this works on iOS. And we do get a little KSP error. Let's take a look. There is a problem with the query, SQL error or missing database, no such table people, because it's called person, right? Let's take a look in people DAO. There we go. This needs to be person. There is no auto-completion here, so that is something that's a bit different compared to normal Android. But let's relaunch this and see if it now works. There we go. And we see our people. We can also confirm this by opening the database inspector here with more tool windows and then opening app inspection and then selecting the process after waiting a little moment. No, apparently Android Studio does not like to attach my app's process, but I verified that before that you can definitely inspect your Room database here as well. I would probably need to invalidate caches here, but you can believe me that this works. I've also relaunched the app, still doesn't work, but we can, of course, rotate our app, survive screen rotations, since it's, of course, persistent. And if we click on an entry, then we delete it. Exactly what we implemented so far. If we then relaunch it, that's the best way to test it. We should have John, Philip, and then our 3 more new entries. And there we go. That's exactly what happens. All right, but we also want to test this on iOS. So far, this is nothing new to how Room works on native Android. But how do we launch this on iOS? So we need to make sure that we go inside of our product hierarchy, find our iOS app folder, open that, then you will find an iOS app Xcode project, open that as well, and then you find this Xcode workspace file. Here we want to right click, open that in Xcode, and then an Xcode window will open up. There we go. And then we can just make sure that we switch to some kind of emulator here maybe. Let's choose the iPhone 14 Pro and hit run. So we don't need to do any adjustments in Xcode. That's the very cool thing about Compose Multiplatform. Let's wait until this builds and hopefully the build succeeds and we get to see our app in here. Yep, it finished building. There we go. And we see our 3 people. Awesome. It also works on iOS. We can of course also delete people here by clicking on them. And if we then relaunch, we will see that it's really persistent storage. So we only remain with Philip, and then we add our 3 new people after a successful relaunch. Isn't that cool? Slowly, KMP is really going somewhere. I think it's really promising, and I'm very much looking forward to its future. And if you are an Android developer or a KMP developer and you just feel like, okay, there's so much out there, so many different technologies, and you understand them, you know how to implement such a Room database, but you really struggle to glue things together. You really don't know how to really build a scaling app with good architecture that is testable. You don't know how to write test cases for that, and you just feel a little bit lost. Then I will put a link down below where you can apply to my 10-week mentorship program, where we will work together really closely over the course of 10 weeks. I will provide code reviews. You can ask me anything you like 7 days a week, and we will work on your technical struggles really, really closely. You can apply for free down below in case you seem to be a fit. we will hop into a 50-minute call with each other where we talk about all the details. And if both of us then still say that sounds like a fit, we will make it fix. Awesome. Thanks so much for watching. Have an amazing rest of your week. See you back in the next video. Bye-bye.